Okay, here we are back and we're going to solve some more trig proofs. So we did some of these in class on Thursday and Friday, so now we're going to tackle them even more. We're going to do a little more complex ones. So let's dive right in. All right, so here we have secant x cosecant x equals tan x plus cotangent x. All right, so again, on any of these, we are then just going to pick one side to start with. All right, so like anywhere, let's see, what do I want to do? This is one. Let's actually just pick this side. Okay, so here tan x and cotangent x, so I can change tangent to sine x over cosine x plus cosine x over sine x, because those are our quotient identities. Remember, do not switch over this line. This line is our boundary line. We do not cross things over that equal sign. It's not like an algebra proof, okay? We just stick to one side of the problem. Okay, so when we add things together, we need a common denominator. So here we have cosine x sine x. So the common denominator would just have to be cosine x times sine x, because that's the only way to the same. So this then I would have to multiply sine x from both the top and the bottom. So sine x over sine x times our sine x over sine x. Over cosine x. This is cosine x. Okay, plus, so this was cosine x over sine x, and I want this to be sine x cosine x, so I'm going to multiply both the top and bottom by cosine. So times cosine, put a little parentheses around there, so we know I'm multiplying by something new. Okay, so sine times sine is, now I'm going to have sine squared x over sine x cosine x plus cosine times cosine is cosine squared x over sine x cosine x. So now that I have common denominators, I can combine my fractions together, because again, this is all just one term. These were two separate terms, so I want to combine these together. So I get sine squared x plus cosine squared x all over sine x times cosine x. Oh, well, last time we learned our Pythagorean identities, sine squared and cosine squared. Well, that gave us 1. So this is 1 over sine x cosine x. So 1 over sine x. So I'm going to now move this over here. So we want secant x cosecant x to equal. So this is 1 over sine x cosine x. So I'm going to split this. So 1 over sine x. So I can rewrite this as 1 over sine x times 1 over cosine x. And 1 over sine x is, this is cosecant x. And 1 over cosine x is secant x. And that is the same thing as secant x, cosecant x. And I have now proven our trig function. All right, so what we always want to do, remember, is stay on one side of the formula. It does not matter which side you choose. You should be able to work it through each side. One side is usually easier than the other side. And a good tactic that I like to use is getting it in terms of sine and cosine. Because sine and cosine are just some natural, easier trig functions that allow us to move, just have a little more flow through the problem. All right, let's try another one. right? This is fun. Okay, so just like we did before, we're going to draw a little line. So, all right, so this side looks a little nastier than this side. So I'm going to kind of focus now on the left side. Okay, so 1 over cotangent A minus cosecant A plus cotangent A plus cosecant A. Okay. All right, so couple different routes we can choose here. We could get it in terms of sine and cosine if we didn't really know what to do, but I can also think back at our Pythagorean identities. So one of our Pythagorean identities that we figured out was cosecant squared theta equals 1 plus cotangent squared theta. So when we had this, if we rearranged it, we figured out that cosecant squared theta minus cotangent squared theta equaled 1. All right. Well, I think we can probably use that. So cosecant squared minus cotangent squared. Well, I can get squared terms if I multiply these by each other. So if I take 1 over cotangent A minus cosecant A, and I multiply that by cotangent A plus cosecant A, this becomes a difference of squares. Because we learned in algebra class, this is why that algebra 2 becomes very, very important, because it kind of sets us up for all these little tricks that help us when we get here. As we sit here, so we're multiplying this by cotangent A minus I'm sorry, my hand is less on my pad and it's making me hard to write. Cosecant A, cotangent A minus cosecant A. All right. So what that gives me is I have cotangent of A plus cosecant A all over cotangent A or cotangent squared A minus cosecant squared A over here, and then I can add that with cotangent of A minus cosecant of A all over cotangent squared A minus cosecant squared A. All right. So now, as we add these two things together, I get cotangent and cotangent becomes 2 cotangent of A. Cosecant minus cosecant, well, these are going to cancel out. So my numerator is just going to have 2 cotangent of A over cotangent squared A minus cosecant squared A. All right, now, so up here we figured out that cosecant squared theta minus cotangent squared theta equals 1. So that would mean that if I switched it, if it was cotangent squared theta minus cosecant squared theta, that would mean that I would have factored out a -1, so that would equal -1. So basically, this whole denominator here, this is the same thing as -1. So what we are left with is -1 times 2, so -2 cotangent of A equals -2 cotangent of A, and we have just proven our trig function. Okay, that one got a little involved and really kind of in there with our trig function and knowing our Pythagorean identities that cotangent and cosecant want. A lot of these take a lot of little math and a lot of stuff that we have done in the past, and you got a lot of that algebra knowledge, so you really got to work with it and try it out. So we're going to do one like this for homework. So what I want you guys to do now is you try one. So we're going to use a difference of square one for your homework, where I'm just going to give you, but I'm going to give it to you in terms of cosine and sine. Okay, so I'm going to give you 1 over 1 minus cosine plus 1 over 1 plus cosine. And that's, I want you to prove that that equals 2 cosecant squared x. All right, and then we can talk through that on Thursday or Friday back in class whenever we are going through this second more complex trig function or trig identities day. All right, see you guys then.